In the name of God, Fluid Mechanics, Chapter 10, Open Channel Flow. Motivation first. An open channel flow denotes a flow with a free surface touching an atmosphere. Like a river, canal, flow, closed dot flow that was described in the chapter 6. Closed dot flow, chapter 6, are full of flow. Either liquid or gas. Have no free surface within. And are driven by pressure gradient along the dot axis. Anyway, the open channel flows are driven by gravity along. Let me write in the next page. The open channel flows here are driven by gravity along, and the pressure gradient at the atmospheric interface is negligible. Interface. The basic force balance in an open channel is between gravity and friction. In open channel, is between gravity and friction. Open channel flows are an especially important mode of fluid mechanics for civil and environmental engineering. One needs to predict the flow rate and water depth that result from a given channel. Flow rate, important. Water depth. That result from a given geometry. Whether natural or artificial at a given wet surface roughness. Natural or and a given wet surface roughness. Water is almost always the relevant flow and the channel size is usually large. The open channel flow are generally turbulent, three-dimensional sometimes unsteady and often quite complex. Excuse me. Let me write the main specification of water is the almost always the relevant fluid and the channel size is usually large. Thus, open channel flows are generally turbulent, three-dimensional. Sometimes unsteady and often quite complex. This chapter presents some simple engineering theories and experimental correlation for a study. Simple engineering theory and experimental correlation. For a steady flow, in a straight channel. On regular geometry, we can borrow and use some concept from dark flow analysis, hydraulic radius, friction factor, and head. Head loop. Simply stated, open channel is the flow of a liquid in contact with a free surface. As we said before, there are many practical examples: both artificial flows, spillways, canals, weirs, drainage, ditch and culverts, and natural stream, rivers, and flood plains. This chapter introduces the elementary analysis of such flows, which are dominated by the effect of gravity. The presence of the free surface, which is essentially at atmospheric pressure, both helps and hurts the analysis. It helps becomes the free surface. There are many practical examples, as we said. This is essentially at atmospheric pressure. Pressure both helps and the pressure can be taken as constant. Along the free surface. Which therefore is equivalent to the hydraulic grade line. Unlike its flow in closed dark, the pressure gradient is not a direct factor in open channel flow, where the balance of force is confined to gravity and friction, but the free surface, let me write the pressure gradient is not a direct factor in open channel flow. we have to force, friction, and gravity. But the free surface complicated the analysis because its shapes is prior unknown. Complicated. Because its shapes is a prior unknown. This was an introduction to the open channels. The next video is continues this introduction with the one-dimensional approximation.